Welcome students again in the chemistry class. Now there are various types of classification of these polymers. We are learning this fourth type of classification of the polymers. The first type of classification is based on the origin or source. The second one is based on the structure. The third one is based on the mode of, that is polymerization, and this is the fourth type of classification now of the polymers. Now this classification of polymers are based on the intermolecular forces which are present between the that is monomers of that polymers. Now when monomers join and form a large molecular weight polymer, then what happens? These intermolecular forces are different into them. Now we learned already into the 11th standard how many intermolecular forces are there present between the molecules, and they are of different types such as dipole-dipole interaction, dipole-induced dipole interaction, van der Waals forces, or it is also called as the London forces, that are the intermolecular forces, and again the ionic forces, etc., covalent bond forces. Now here on the basis of all these forces, these plastics are of various types, or the polymers. Plastic means polymers are the various types, and the polymers are classified into here 4 different classes or categories, and which depends on the elasticity, the tensile strength, again the toughness of that polymer, and this is it is directly depends on the intermolecular forces which are present into the polymers. Now let us see which are these that is different categories and how they are different from each other, and how they can be used in the everyday life as a domestic purposes. Now let us see first one class of this. Now see here, polymers are classified. Now this is the classification of polymers on the basis of intermolecular forces. Now polymers are classified into 4 classes on the basis of intermolecular forces, which depends on the elasticity, toughness, tensile strength, and again the forces, intermolecular forces between them. Now first one class of this type is the elastomers. As the name itself, that is they are the elastomers, that means in these polymers there is definitely the elasticity. That means on applying the force they get stretched, and on releasing the force they get to the original shape again. Such type of plastics which are used in, for example, hair rubber bands, etc., and such that is the polymers are called as the elastomers. Now elasticity is the main property of these polymers. So elasticity is the property by which a substance gets stretched by external force or applied force and restores or comes again restores its original shape on a release of that force. Now this is the property of elasticity is present into these elastomer polymers. Now elastomers, the elastic polymers. Elastomers are also called as the elastic polymers, which have weak van der Waals forces in them, and due to which they permit or allow the polymer to be stretched. The weak van der Waals forces or weak intermolecular forces permits these molecules of these polymers to be stretched. Now, what is there? The elastomers, that is the elastic polymers, have weak van der Waals forces which permit or allow this polymer to be stretched. A few cross links between the chains are always present into these elastomers. There are very few cross links, and due to which what happened? Due to the few cross links between the chains helps these polymers, helps the stretched polymers to retract to its original position. Retract means comes again to the original position or get, that is the compress. Now when there are the few cross links are present, few cross link chains are present in these elastomers or elastic polymers, due to which these polymer, that is due to which it helps the stretched polymer to retract its original shape or position, to come again its original shape or position. And on removal of that applied force again, what is there? On removal of the applied force, these polymers come again to the original shape. What is there? A few cross links between the chains help the stretched polymer to retract to its original position on removal of the applied force. And which are the examples of these elastomers? Very important polymer, that is the elastomers in the everyday life. And for example, vulcanized rubber. Vulcanized rubber means there is addition of sulfur into the rubber, due to which the rubber gets elasticity. There is the cross link between the sulfur atoms and that of the rubber molecules, and due to which that vulcanized rubber on relieving the stretch again come to its original position. So the hairband, that is the hairbands plastic, is the best example of these elastomers. Now let us see the another examples of these elastomers. Now see Bauna S and Bauna N. Now these are also the very elastic plastics. We will see how they are prepared into them. There are the that is the cross links are present which retract the stretched polymer again to come back into its original shape. And neoprene is the best example of these elastomers from which the hairbands are prepared. And these are the elastomers or elastic polymers. Now second category of these that is the polymers which are we classified on the basis of the intermolecular forces, and the second main, that is the category or class of these polymers, is the fibers. Now you know the fibers, that is the long thread like structure, fibers. Now in everyday life so many uses of these elastic fibers or polymer fibers are there. That is the our toothbrush have that threads of the polymer. Again the nylon 6 and nylon 66 fibers which are used for the preparation or manufacture of the fish nets, ropes, etc. And these are from these, that is the fiber polymers. Now which type of intermolecular forces are present in them? Let us see. Now these fibers, polymeric solids. Fibers are in the solid state. We know that the polymeric solids which form thread are called as the fibers. Thread, that is the long fiber, long thread can be prepared by the polymeric solids, and that polymeric solids from which the thread-like structure is prepared are called as the fibers. The fibers possess high tensile strength. Now this is the very main characteristic of the fiber, that is they have the high tensile strength, and we can stretch the fiber in any desired, that is width, as thin as possible. Now due to that of the high tensile strength, that is possible to stretch the fiber in a desired, that is the very thin thread. Now the fiber possesses high tensile strength, which is a property to have resistance to breaking under tension. Yes, that is also very important property. Though we stretch the fiber into a very thin thread, but it does not get breaks. And this property, that is the fiber, have the high tensile strength, which is the property to have resistance. Resistance means not break. on breaking, or that is they are capable to sustain that breaking. Sustain that breaking. That means there is no breaking on that is the stretching of this fiber. They sustains the breaking. So the fiber possesses high tensile strength, which is a property to have resistance of breaking under tension. Now they have the resistance, that is they have the capacity to breaking on tension. That means they do not break on tension, means on applying the force for the stretching. This characteristic property is due to the strong intermolecular forces. Now that is very important. Why the fibers can be stretched into a finest long thread? Due to the property which is the very strong intermolecular forces are present. And which type? Like hydrogen bonding. You know that hydrogen bondings are very strong intermolecular forces. Again the dipole-dipole interaction, which are also very strong, which are generated due to the electronegativity difference. Again, due to which the fibers are crystalline in nature due to these forces, that is the hydrogen bonding, dipole-dipole forces or dipole-dipole interaction, due to which what happened? Due to which these fibers are the crystalline in nature, that have some crystalline like nature, that is some shining into them. And for example, the best example are the polyamide fibers, and there are two types of polyamide fibers or polyamide polymers, and that are the nylon 66 and nylon 6. Now we will see later the manufacture of this nylon 66 and nylon 6. Now in the last lecture, yesterday lecture, I told you about the nylon 6 from the epsilon caprolactam, that is the monomer from which the nylon 6 fiber or polymer are formed, and the name nylon 6 is due to the 6 carbon atoms are present into the monomers. And similarly nylon 66 also have the name due to two types of monomers are there, and in both types of monomers there are the 6 carbon atom. So the name is nylon 66. Both are the polyamide fiber, that means there is the amide linkage, C double bond O NH linkage. Now you will see in the, that is the nylon 6, in the that is nylon 6 there is the polyamide linkage or amide linkage, C double bond O NH type of linkage is called as the amide linkage. And so many amide linkages are there. So these fibers or polymers are called as the polyamide fibers. And the another example of this fiber is the polystyrene, or it is also called as the terylene, or in USA it is called as the dacron, from which textiles, that is clothes, different types of trousers, wearing trousers, etc. can be prepared. Now these are the two best example of the fiber, that is the polyamide nylon 6 and nylon 66, and polystyrene, that is the terylene or dacron. Now third type of category or class of this type of polymers is the thermoplastic polymers. Now as the name suggests, they are thermoplastic. Thermoplastic means what? On heating or on supplying heat, they can form the liquidy mass, or they can be molded, and on that is relieving the heat or on cooling, they again gets hardened. Now softening and hardening are there on supplying the heat. These polymers or these plastics gets softening, and on cooling these polymers get hard. Now what is again which type of forces are in them? Let us see. Now thermoplastic polymers, as the name suggests, plasticity is a property of being easily shaped or molded. What is the property of plasticity? That means they can be easily shaped or molded on softening. You know the molding. If we want any type of shape of the, that is the object or any utensil, then we can mold these plastic into the desirable shape on molding. Now plasticity is a property of being easily shaped or molded polymers are capable of repeated softening. That means on heating it gets softening, and on cooling it gets harder, and again the hardened polymers on heating get again into the soft polymers. Now this is repeatedly we can do. But there are some another plastics also which cannot be molded on heating. That means which cannot be softened on heating. That are the different another type of the plastic. Now these are the thermoplastic. Now the thermoplastic polymers being easily shaped or molded, thermoplastic polymers are capable of repeated softening on heating and hardening on cooling. Now this polymer possess moderately strong intermolecular force. Moderately strong means the intermolecular forces are in between or intermediate between the forces of the elastomers and between the forces of the fibers. That means they are not as strong as the forces of the fibers, or they are not as weak as the forces of the elastomers. That means they are in between. The intermolecular forces are always moderately moderately strong between the intermolecular forces of the elastomers and fibers. Now, which are the examples of these thermoplastic polymers? The polymers of the bottles, water bottles, is the best example. And which are that? Polythenes. Again, polystyrene is the another example. And polyvinyl, these are the third example. Polythene, polystyrene and polyvinyl. These are the three examples which are the best example of these thermoplastic polymers. Now let us see the fourth type of this class, which is based on the that is intermolecular forces of present in the polymers. Now see the fourth class of these polymers which are based on the intermolecular forces. Now first one is the elastomer, second ones are the fibers, third one are the thermoplastics, and the fourth one now here that is the thermosetting polymers, or they are also called as the thermoplastics also. They are called thermoplastics. Why the thermosetting or thermosetting plastic, the name of this polymer? That means once they get molded or set during when they are hot and on cooling, though we heat them again, but they cannot be remolded or reshaped again. Such plastics or such polymers are called as the thermosetting polymers. Now exactly opposite that of the thermoplastic polymers. Now the thermosetting polymers, see here what are given, which are the points and which type of intermolecular forces are present, that is very important. Now this is the fourth class of these polymers which are based on the intermolecular forces. Now thermosetting polymers are very rigid, that is tough, rigid polymers. During their formation, when they get formed, they have property of being shaped. When they formed initially, they have the property to mold or shape, but shaped on heating, but they get hardened while hot, and once hardened, they becomes infusible. They cannot be fused again. That is, cannot be softened again by heating, and therefore cannot be remolded or reshaped. Now understand this. Pay attention here. During their formation, they have property of being shaped or molded on heating, but they get hardened while hot. At that time they get hardened, and once hardened, they becomes infusible and cannot be softened again or by heating, and therefore reshaped or remolded, and therefore these polymers are called as the thermosetting polymers. This characteristic property of the thermosetting polymers, which cannot be reshaped or remolded again, is due to which type of forces? Due to the extensive cross-linking of covalent bonds are formed in them during hardening. Remember that. When these polymers get hardened, while they are in a hot condition, at that time what happens? Very intensive type of cross-linking, that is more cross-linking of the covalent bonds are formed between their molecules, and due to the extensive, that is the maximum cross-linking, that is why they have the property to cannot be remolded or reshaped again on hotting or on heating or becoming hot. They cannot be remolded again. This is the property due to the extensive cross-linking of the covalent bond formed in them during the hardening or setting process. When they are hot condition, when they are in the hot condition, in the hardening process or setting process, there is formation of the extensive cross-linking between the covalent bonds of their molecules, and this is the characteristic property of that is do not remolded again is due to this region, that is the extensive cross-linking between their molecules of the covalent bonds when they are getting that is the in a set manner or in a that is in the remolding. There is not possible when they get mold or shaped or setting. The property is due to the cross-linking of the covalent bond, which is the extensive in these polymers. And the best example of these thermosetting plastics are bakelite and urea formaldehyde resins. Now these are the polymers. We will see the manufacture of preparation of these two types of polymers also in the next, that is the topic, how the bakelites are prepared and how the urea formaldehyde resins are prepared. As the name suggests, they are these resins. Resins means polymers or plastics. They are formed from the urea and formaldehyde. Now these are the best example. Bakelite is also the best example of this thermosetting plastic. That is the rings of the cookers are made from this bakelite, and we know that the rings of the cookers are not remolded again. Now again there is the fifth type of classification of this polymer. We completed already the 4 different types of classification of the polymers, and this is now the fifth type of classification of the polymers, and this is based on the basis of different types of monomers used during the preparation of these polymers. Now classification of polymers on the basis of type of different monomers. Which type of monomers are used during the preparation of these polymers? That is the basis of the classification of these polymers. And there are only two classes or two types which are based on the type of the monomers. And first one is the Homo Polymers. And the name suggests they are Homo Polymer means there must be the same type of monomers during the formation of these Homo Polymers. Only one type of single type of monomers may be present. In very few cases there are the two types of monomers, but generally the single monomers are present in these Homo Polymers. Now the polymers which have only one type of monomers or repeating units are called as the Homo Polymers. Usually they are formed from the single monomers, and the best example of these Homo Polymers are polythene. Only ethene molecules are there in the polythene. That is the single monomer. Again the polypropene. Polypropene means only the propene molecules may be present into that. Nylon 6, you know that there are only the epsilon caprolactam monomers in nylon 6. And nylon 66 is also the another example, but into that there are the two different types of monomers. Few examples are of the two different type of monomers which in the sequence. So there is the homogeneous nature of these, that is the polymers. Now the another polymer is the copolymers. The second type based on the type of the monomers. Now these, as the name suggests, they are copolymers. That means there are two or more than two different monomers may be present into these copolymers. The polymers which have two or more types of monomers, that is the repeating units, are called as the copolymers. Now definitely they are formed by the polymerization of two or more different types of monomers, and they are randomly sequenced. That means there is no that is the orderly sequence into them of the monomers as that of the Homo polymers. There is the orderly sequence of the monomers. But in copolymers, the sequence of the monomers are random, and therefore they are called as the copolymers. And the best example are the Bauna S and Bauna N. We will see the preparation of this Bauna S and Bauna N also in the next topics. There are the preparation of Bauna S, Bauna N, urea formaldehyde, resin, bakelite, nylon 6, nylon 66, steriline, so many that is the polymers we have to prepare by using the different monomers. We will see that preparation also. Now if student you like this that is the of my studying to you, that is this video, and if you understand better by this, that is the topic, or by this lecture, then you can subscribe, like and share this video to the others and tell them to subscribe and get benefit from this video. Thank you very much.